Hey math kids, today we're going to talk about solving exponential equations using logarithms. And so this is really the power of logarithms in my opinion. So we want to solve this exactly. And so we have a big 2, and so the way we undo a big 2 is we use a log base 2. So big 2 cancels log 2, log base 2. And so that would be our exact answer. Now part B says use your calculator to evaluate the solution correct to 2 decimals. So we want 2 decimal places. And so we're going to have to use the change of base formula. So we're going to say natural log of 30 over natural log of 2. Go to our calculator. So we go natural log 30 divided by natural log of 2. And we end up with 4.91. That's essentially it. Okay. So it says find x exactly. So that means we don't have to plug it into a calculator. All right. So if we have a big E, the way we undo that is we do natural log on both sides. So E cancels natural log. We're left with x equals natural log 30. Now if we have 3e to the x halves equals 21, what we're going to have to do first is divide by 3. E to the x halves equals 7. We undo the e with a natural log. So we get x halves equals natural log 7. And then we multiply both sides by 2. So x equals 2 natural log 7, which is, that answer works. We could take it another step further if we wanted to, bring this up here, and we could say natural log of 7 squared, which is natural log of 49. So really, any of these are fine. The book used the one that's in yellow, 2 natural log 7. So if you want to use that as a guide, you can use that one. Okay, find exactly the points of intersection of y equals e to the x and y equals 1 minus 3e to the negative x. And then check with technology. So if we want to know where two things are crossing, we set them equal to each other. And then we try to solve for x. So when we're doing this, we want to get everything onto one side. So we're going to get e to the x, and then minus 1 plus 3e to the negative x. So minus 1 plus 3e to the negative x equals 0. Now if we multiply everything by e to the x, so this is going to be e to the 2x minus e to the x, and then these will cancel, so it's plus 3 equals 0. So this is going to be one of those weird, like, hidden quadratic things, because if we say e to the x is equal to u, then this becomes u squared minus u plus 3, and that's a pretty simple quadratic, because we can do 1 and 3. Let's see, hold on. That's not going to work out. Let's see. Did I mess that up? I messed up from the beginning. I wrote down the wrong equation. There's a minus 3 right here. Okay, so I'm going to have to just redo that real quick. Sorry about that. Because that can't be factored the way that was. Okay, let's try that one more time. So we set these equal to each other. So e to the x minus 3 equals 1 minus 3e to the negative x. Get everything onto one side. E to the x minus 3 minus 1 plus 3e to the negative x equals 0. Combine those like terms. E to the x minus 4 plus 3e to the negative x is equal to 0. And we multiply everything by e to the x, including this side. Alright, so that becomes e to the 2x minus 4e to the x. And these would end up canceling because when we add them, they become a 0, which means e to the 0 is 1 times 3. So that's still 3, and then those multiplied together are still 0. Okay, we use our u substitution. We're saying u is equal to e to the x. And after we do that, we get u squared minus 4u plus 3 equals 0. T factor that. Make those both negative. So we have u minus 1, u minus 3 equals 0. And if we break those both up, we have u minus 1 equals 0, u minus 3 equals 0. Now we're going to substitute this back in, so it's e to the x minus 1 equals 0, and e to the x minus 3 is equal to 0. Add 1, e to the x equals 1. And then to undo the e, we natural log both sides. And so x equals natural log 1. This is something you'll just need to know, but log of 1 of anything is 0, and that's because when we graph it, it always crosses at 1, and so the y value right there is always 0. And so this one, x equals 0. Now over here, we add 3, e to the x equals 3, undo the e by using natural log, so x equals natural log 3. Okay, so those are our two exact answers. And we need to know the points where they cross. So these are just the x values. And so we plug that into one of the originals. So I'm going to do this one. So e to the x minus 3. So e to the x minus 3. But if I plug in a 0, I get e to the 0 minus 3. E to the 0 is 1. So 1 minus 3 is negative 2. And so that point is going to be 0, comma, negative 2 is one intersection. And then this one, if I do e to the x minus 3, I do e to the natural log of 3 minus 3. And so e and natural log cancel, so that's 3 minus 3, which is 0. So that means natural log 3, comma, 0 is the other place where that crosses. And they want us to check using technology. And so what I'm going to do real quick is I'm going to change that natural log 3 into a decimal. And so that's 1.10 if we do 3. Okay. Now, if we graph these, let's go back to the original up here. Okay, so clear. So we have 1 minus 3 e to the negative x and then we have e to the x minus 3, and we graph. we're hoping, if we did everything right, that those cross at those two places. Now, it's really hard to see. So I'm going to zoom in right there to see if we get a better picture of where they're crossing. Okay, so 0, -2 definitely looks like a possibility. And basically 1, 0 also looks like a possibility. So I feel pretty confident that those are good, but let's check them. So we do an intersection, curve 1, curve 2. Now this is the one that should give us the point 0, -2. And it does 0, -2. And then let's check the other one. Go to intersect again. Curve 1, curve 2. This time we want to test this one. And we get 1.01 if we round it. Or sorry, 1.10 if we round it, comma 0. And so that did check out. So let's move on to the next one. Let's see. All right. Need some room for this one. Okay, it says a farmer monitoring an insect plague finds that there's an area affected by the insect is given by this equation. Okay, where n is the number of weeks. Okay, use technology to help sketch the graph AN. So sketch, and then estimate the time taken from the affected area to reach 5,000 acres. So this is in acres also. Okay, now, so we're going to graph it. So we have 1,000 times 2 raised to the 0.7 x. Just to be safe, let's put this in parentheses. Okay, so we want to graph that. And it's not fitting, so that makes sense though. So we go to the window. So we're gonna, let's do it like 0 to 5 maybe on the x, and then let's go to like, I don't know, 8,000, so like 0 to 8,000. Alright, we'll see if that works. Okay, that looks pretty good. Now, they wanted us to estimate when it was 5,000 acres that were affected, so that's where I'm going to add 5,000, and we just want to see where they cross. Okay, so we just need to find this, so we go second, calc, go to the intersect, curve 1, curve 2, guess where they intersect. It looks like it's about 3.32. Okay, and then if we really want to sketch this, we can from this graph, but it's just essentially going to look like this, and this is our 5,000. Okay. Now, now we're going to check our answer by doing it by hand, which is kind of, feels a little backwards to me. I would have done it by hand and then checked it with technology, but whatever. So what we're going to do is we're going to plug in 5,000 for this, and then we're going to solve for n. So we get 5,000 is equal to 1,000 times 2 to the 0.7 n. So on the algebra, so on the algebra, we're going to first divide by 1,000. So 5,000 divided by 1,000 is 5. Okay, the way we undo a big 2 is we do a log base 2. So this cancels this, and so we have log base 2 of 5, which equals 0.7 n. And we divide by 0.7, divide by 0.7. And so we end up with log base 2 of 5 divided by 0.7 equals n. Okay, now we need to figure out what that is. So if we want to do log base 2 of 5, we'll figure that out first. So natural log of 5 over natural log of 2, and then all of this is divided by 0.7. So we go to our calculator, we do natural log of 5 divided by natural log of 2, and then we divide that by 0.7. That gives us 3.32, and I think that was the same thing we had. Yep, 3.32, 3.32. So we verified that we got the same thing using both methods. Now, if you need additional help, please come to Math Lab. Until then, calculator.